Hey guys, this is Anand from AnandTech.com. Here we are with episode 5 of the AnandTech Podcast. This is a bit of a special episode. Once again, it's just myself and Brian Klug, our senior smartphone editor.
Hey guys.
So Brian is actually in Korea right now. I'm back home in Raleigh. We were both in San Francisco last week. Initially, I was there for the Intel Developer Forum, and Brian joined me for the launch of the iPhone 5. This is a special episode because we're primarily going to focus on that, although we will have a little bit of discussion about Haswell in here as well. So, Brian, how's Korea? Are we allowed to say why you're in Korea yet?
I don't know if we are, but it's
Okay.
pretty obvious, I think. I don't think we have said yet.
Okay.
But
Well,
when
and
this
there's
post,
there.
it'll probably be obvious. We'll see.
Okay, that's good. Obviously, there are a lot of companies in Korea. And Brian, this is your first time in Korea?
That's right. Yeah. So, yeah, I can't read any of the text. Obviously, I don't speak Korean, but so far it's been good. Yeah, no real problems. Although there's a
And
typhoon that's going to come this evening. So we'll see how that goes. It's already raining kind of considerably outside.
it's like a major departure from Tucson.
Oh yeah, this is definitely a major departure. But I mean, rain for me is pretty novel. So I'm not like, oh no, it's too bad that it's raining. I'm like, yay, it's raining. This is, like, what's this stuff? So
So it doesn't rain in Tucson much at all.
not until it's like monsoon season.
Okay.
Like actually right now it's been rainy, but then it kind of stops, and then it's sort of novel. But
And you've been so obviously there are a lot of and what part of South Korea are you in right now?
I'm in Seoul, so the
Okay,
capital, just like downtown, right in the center of things.
that's awesome. I've never been, so can you explain like what's the describe where you are? What's the I don't know. If you were writing a review on it, what would it sound like? How would you describe it?
I don't really know. I haven't gotten enough of like a look at everything. I mean, obviously this is a mega city, so far it seems really nice. I mean, the places that I've seen have been really clean. Obviously well off, well to do. I mean, yeah, it seems like they have a lot of great things. And we're going to do some sightseeing later, I believe. Get to go to the DMZ, see some other sites, I guess. But yeah, I'm pretty impressed. Obviously, yeah, the thing for me has been, like this is the land of internet. Like internet is really fast here. Like
So how
the
fast is
hotel
really
internet
fast?
is like 100 megabits. And the cellular stuff is 20 megahertz LTE that they gave us. So I'm having a field day. But
So put it in perspective. What kind of LTE do we have here in the States?
in the US, it's all 10 megahertz is the channel bandwidth. And AT&T has some 5 megahertz markets. And
And then what's the relationship between channel bandwidth and speed?
directly proportional. So like maximum that you can get on 10 megahertz is like 73 megabits if you're on category 3 device
Hmm.
and you're in the best conditions. Maximum that you can get on 20 megahertz is 100 megabits for category 3, 150 for category 4.
Oh
So yeah,
wow.
there's a considerable difference.
Now, what's the highest you've ever seen in the U.S.? Like when I did the Galaxy S2 Skyrocket, whatever they called that thing, on AT&T LTE in DC, I think I hit maybe just under 60 megabit, like something in the upper 50s.
That's like the maximum. Yeah, you can't really get much faster. You can get close to 70. I've seen some people hit maybe 70. Um, there's one guy on Twitter who I talk to regularly. He in New York City always goes to some Starbucks, I believe, and there's a DOS endpoint in there, and he can get like 70 on Verizon.
That's
But
awesome.
yeah, it's really hard to get. Like 73 is the maximum, and it includes overhead, so you should be able to get really close to it. But
Okay.
yeah, 60s and 70s are pretty much the highest I've ever seen.
Now,
And
have you broken that yet in Korea, or you just haven't walked around enough
no,
yet
I
to?
haven't. But I mean, I'm in a hotel and it's downtown, so I don't expect that I'll get to, break that. But maybe walking around a little bit more, I'll find a little bit better. So far it's been like 20s, 30s, which is still pretty amazing for, a big urban area. But we'll see.
Now, so you said the relationship between channel bandwidth and speed is directly proportional.
Yeah.
Um, there's also that trade-off for, simultaneous users, isn't there? Like it's
Yeah, there's more subcarriers. Yeah,
okay.
so I mean, an OFDMA system like LTE, yeah, you multiplex, both with the code. So there is some, like code division, multiple access, and then you also, it depends on whether you're getting all the subcarriers or you get a subset. So yeah, it is proportional. The capacity scales that way.
Gotcha.
So
And
it really
actually,
doesn't
so
make sense to run like two 10 megahertz LTE carriers. Just go for the 20.
okay. And now, is that 20 up and down or 20 aggregate?
It's 20 up and down. That's right. Yeah.
Okay. And then, so you discussed kind of max on category 3 for 10 megahertz and 20 megahertz. What is it for 5?
Category 5?
No, for 5 megahertz channel
Oh,
bandwidth.
I don't know. See, it isn't exactly proportional. It depends on how
Okay.
many subcarriers there are. And I don't have that math in front of me, but you can calculate from the subcarriers.
Okay.
5, I forget. I guess I should figure that out for the AT&T markets. Because I know you're in Raleigh, and that's another 5 megahertz market.
Yes.
There's a few of them. All the ones that they announced when they did that announcement earlier this month, when I was in New York, that all
Yeah.
those new markets that they lit up were 10, except for one, which I can't remember.
Is
But
now AT&T is bringing LTE to Tucson finally. Is that going to be a 10 or a 5?
that's 10. Yeah.
Oh,
So I mean,
nice.
you can look that up just on the Spectrum dashboard and see what licenses AT&T has in your market, and then from there it's pretty obvious. Just look at the 700 megahertz band, and then you can immediately tell what they're going to run. So yeah, I know in my market they have 10, so there's no reason that they're not going to go for the full 10. And whereas in yours it's they only have 5, so they can only run 5. And then they have AWS holdings, and later on the AWS holdings will start getting lit up, and we'll see that happen, which will be interesting.
Yeah,
But
so I'm curious, what happens? So AWS is what frequency is AWS?
that's 1700 and 2100. So you have the uplink on 1700 and the downlink on 2100. So they have it split up a lot like that just because that was what was available at the time. So but yeah, it's 1700 and 2100, but it's not like both are on that sort of band. And I'm doing air quotes because the uplink and the downlink are separated by a substantial amount. Like I think it's like 400 megahertz. Yeah, that's right. 400.
And then when AT&T or starts using AWS for LTE, what is going to happen to all their 700 megahertz deployment?
They'll keep that around. Yeah, this will
Okay.
be a way to boost capacity, and maybe in the future aggregate, both of them together. And eventually Verizon has to do the same too. They have AWS, but they just haven't started. They haven't done anything with it yet, and everybody's kind of holding their breath, waiting for when that happens. And it has to happen eventually. Otherwise, I don't know what's going to happen. But yeah, we'll
So,
see.
when you say that they're going to use AWS to kind of boost capacity, how will that work on a device level, right? Will you just have devices that'll work on
On both.
1700, 2100, and 700, and then it'll just switch depending on what's available?
Yeah, that's right. So you'll support both. I mean, it's basically how it works right now. So you have 850 and 1900 for Verizon and CDMA 3G, and then you just get handed off between them, and they sort of load balance. And of course, if you have a device that's 700 only, then the load balancing takes place with the other users no longer being only on 700 exclusively. So like, band 13 for Verizon will start being less loaded
I
if they
gotcha.
if they deploy AWS. Band 17 will start being less loaded if you're on AT&T. But I mean already AT&T has devices that are, you know, what is it? It's band 4 and 17. So those already are out there. But Verizon doesn't have any that will do 4 and 13 currently, just for whatever reason.
Okay.
So, yeah, we'll see going forward what it works out to. This is a little bit of speculation, but yeah.
And do you have like a time frame for when you're expecting this to happen on AT&T?
The
I mean,
AWS stuff, I would
yeah.
say like 2013. It has to.
Okay.
Yeah.
So speaking of LTE, a phone got announced recently with LTE support.
Finally.
Brian, so this was your first Apple event. What is your take people. So, do you want to explain to everyone how that whole thing works, or do you want me to give the kind of overview?
You should give it. Yeah, I don't know what you mean. The whole thing works on like how you get how does one actually get to go to one of those events?
No. The just the how the event unfolds, right? So,
Oh yeah, well I mean this is like pretty standard fare for any major event. I mean you stand in line for like hours beforehand, and then you get released, and depending on how the event coordinator has done their job, it's either like a mad dash, like literally in the case of Google I/O, I sprinted all the way around Moscone twice in a a suit with a backpack full of camera equipment, and then up the escalators, and then through the like seating area to the very front, and then took my seat, and was like completely drenched in sweat and like out of breath because it's not like you go jogging in a suit with like a backpack that weighs 40 pounds.
yeah.
But in the Apple event, it was like the venue was very small and it was pretty orderly, I think,
No, I thought it
despite
was
the
very
last
orderly.
part. Yeah.
I
And
mean, the event started at 10 a.m. If you want a decent seat, you have to get there around 8 a.m. And you line up at 9 a.m. They start registration, so you move from one line to making sure that you're allowed into the event to a next line where you wait for the next hour.
yeah,
And Apple's got like refreshments and stuff there, but no one's really eating because no one wants to give up their spot in line.
exactly.
And yeah, I was thankful that Brian was there because it actually he could hold my spot where I just inhaled a croissant or something. So then you wait in that second line, and that second line kind of stopped being a line. Like I guess everyone just lost all sorts of manners, and it just turned into a giant blob.
That's normally how things go too, is that there's a lot of pressure to get a good seat,
Yeah.
and so yeah, whatever you need to do needs to be done to get a good seat.
Yeah, I feel like we weren't too bad, right? I didn't like step on anyone or push anyone.
No, we're never that way, but I'm saying, like if there are other people who are, what should I say? They're more aggressive, like, but I mean that comes with the territory, I guess. I'm not
Yeah.
holding it against anybody.
No, so like 15 or so minutes, doors open and the like just the amorphous blob of press are funneled into the venue, and then we all kind of sit down, and then it's just unfolding of everything: notebooks, cameras. Brian, you brought a USB hub, right? Like
Yeah, I've
what?
started bringing a hub. Yeah.
And
So
you
I mean,
had
yeah, I don't know. So this particular one, I don't know. I've had this dream for like forever now of bringing a spectrum analyzer to the Apple event just to see what Wi-Fi looks like. Ever since the like iPhone 4 demo with Bluetooth that didn't work, and ever since there was an I/O demo with like a Logitech keyboard that had Bluetooth that didn't work. And so obviously I was like, why does nobody have an iSpy or something? Because I know the event coordinators must have one. Like getting the Wi-Fi straight at these events not is not like a small concern. It's like something you throw at least, tens of thousands of dollars at and
yes,
hire people. And so I know they have it, but I wanted to see what it looks like because to me that's cool. So I brought a hub, and it's because on the MacBook Pro, obviously the USB ports are like they're spaced like 2 millimeters apart, and if you throw an LTE dongle on there, you immediately can't use the other port. And we needed to do tethered capture because if you bring an iFi card, it's just not going to work.
yeah,
And juggling around SD cards doesn't work either because the SD card reader doesn't work on the MacBook Pro unless you
yeah.
like jam it in. So I brought in a hub and plugged in like three things into it. It was like the LTE dongle, the, the iSpy card, and then the tethered capture like mini USB to the Nikon camera thing. So
And
yeah,
how did the hub work? So I haven't actually used a hub in like
years? Really?
yeah. I mean, I use whatever's like built into the keyboard or to a monitor or something like that.
Sure.
Is this a special hub or just one you got for free somewhere?
No, I actually bought this one. Like I was in an Office Depot with one of my parents,
Yeah.
like with my dad, I think, and he was like, I need to buy some paper or something or like index cards. And I saw like, in the checkout aisle, they have like all this other like junk.
Yes.
And I saw this USB hub and it was made for notebooks and it folded up and the cable like stowed away and It was really compact, and the spacing between the USB ports was great. And it was only like $10 or something. So I was like, wait, I need to buy this like right now. And so I bought it, and yeah, it's worked great for a while. But I mean, it's
So
like
who?
4 ports.
It's a USB 2 hub.
Yeah, exactly.
And who's the manufacturer?
I don't really know. It's like something generic.
Okay.
I just went for
Um,
like whatever was there,
well, because
really.
that's always the issue with these kinds of things, right? Like, I always just end up using whatever the free USB hub is that I get from whoever,
Uh-huh.
and most of the times it's terrible, right? Like it doesn't work or it can't transact data quickly enough, and I guess that's what I get for just using free USB hubs.
That's like the USB storage. Like I told
Yes,
you this, but the ASUS, at one of the ASUS events we were at, like I think it was the Transformer Prime event, right? At Mobile World Congress, they were handing
yes.
out those USB, like they look like keys, like the LaCie key,
Hmm.
and I got one because of course I didn't want to pass it up because it looks cool. And when I got it home, I noticed that it would corrupt whatever I put on it, and it would like corrupt it on a read. I remember we talked about this. It wasn't a corrupt on a write; it was
Yes.
a corrupt on a read. And so I set up a script, and I would write using DD like 100 megs to the disk, and then wait half an hour, and then do an MD5 sum on it. And literally throughout the day, it would keep changing, and it was just amazing because it was like you could use this for random number generation. It kept corrupting so good.
Yeah, because that's actually that's something SSD controllers have to worry about, right? So when you
Yeah.
grab a like a word line or whatever and you read it, there's a chance that it'll disturb the adjacent cell and like knock a bit out of place. Which
Yeah.
I remember Intel they when they introduced the X25M, geez, like 4 years ago, I guess now, they were like, hey, look, this is a problem. Not all controllers do this well. They don't take into account read disturb and all this other stuff. And, I just thought nothing of it. I was like, oh, that's probably not a big deal. I can't see anyone shipping a drive that does that. But in the consumer, like USB commodity flash storage space, that totally happens regularly.
Yeah. Oh, so actually the hub is a Targus.
Oh, okay.
Yeah. It's pretty sweet. That's the Targus model ACH 114 US. Yeah. So that hub is sweet. I can confirm that it works.
That's good. That's
It
good.
does its
Working
job. Yeah.
Working hub recommendations are important. So we sat down. The reason tethered capture was such a big deal is this was technically our third live blog ever of all time, and our first at an Apple event. So we made the decision to do a live blog the weekend before the event. John, our web developer, developed a live blog engine for us.
In like
And
one day, right?
Yeah, he developed and tested it in a matter of 2 days, but it was functional after sub 24 hours. We load tested it during the IDF Day 1 keynote, which was kind of low volume, so it wasn't a big deal. Load tested it again during the Haswell architecture disclosure later that day. And that was pretty good. We kind of peaked at like roughly 300 megabits per second of traffic outbound. And then we kind of re-architected a bunch of stuff, beefed up the server infrastructure, spun up more VMs, and really went at it during the iPhone live blog. And so high level stats: we served over 1 billion packets. We pushed out nearly a terabyte of data, and we actually maxed out gigabit Ethernet on some elements of our network. So we got tons of data captured from all of this. We're going to be able to re-architect a bunch of cool stuff with the site going forward to ensure that we're even more prepared in the future. But the site stayed up, and there were a bit of slowdowns, and I broke the engine. I tried to correct a typo, and we didn't have typo correction support in yet. So if you were watching the live blog and the page stopped auto refreshing and you had to manually refresh it, I broke that. That's I'm the reason for that.
Then there was like an all caps email that was like, "Don't change this."
Yes. So yeah, we live vlogged the event. Afterwards, they kind of shuffle us into a separate building where they, had a surprisingly few number of iPhones. Do you know? Did you ever count to see how many iPhone 5s were there?
I think there were six per table, and they had two tables, and the two other tables were all dedicated to the iPod Touch and iPod Nano.
Okay.
But you
See
missed the
that?
best part. See, like the best part is the like everybody packing up really quickly. That's the thing. It's like you have to unpack quickly because you need to take your seat, but also you need to be able to get out like immediately. And
Yes.
that's the most important part, at least for me. So I just unplugged the hub and like shoved everything into one pocket, and the notebook goes in like the other pocket, and then it's like we need to immediately run off.
What's funny is as quick as we were being to this is a traditional kind of auditorium. We were on the left side of the auditorium. There were maybe 6 or 7 seats in our row. And Brian and I are like maybe the 2 or 3 seats in from the aisle. And as quick as you and I were to put stuff in, the two dudes to the left of us like just had a MacBook Air, right? Like, so they shut that MacBook Air and they were ready to go. And like, I was feeling so bad because clearly they wanted to run out of there and go play with the phone. And we were taking an eternity in their eyes. Like I could
Oh
see the
yeah.
frustration. And then
Yeah.
eventually they just started climbing over seats to get around us.
Yeah, exactly. Like I wasn't super fast because I have all this stuff,
Yeah.
but that's always the difficult part is getting out really quickly. And you know what stuck with me is that venue looks a lot bigger on the video than it is in person. Like in person, it is pretty tiny.
Yes. This is the Yerba Buena. Is it the Center of the Arts?
Yeah, Center for the Arts or something. Yeah,
Okay.
it is really small. Like I don't know how many people. I wouldn't give a guess that I'm going to be held accountable to,
I
but
mean, it is
very
very
small.
I wouldn't consider it to be super small, but like compared to Moscone Center, which is where IDF is, where WWDC was, it's obviously like in a completely different tier of size.
Yeah, compared to the
Um,
other event venues, it's just like very, very small.
so the
So then
phone got
we got to
announced.
the four tables in the room. That's
Yes. And then you proceeded to do a demo. And this video, first of all, I want to apologize. I did a horrible job working the camera on the video. If you saw our hands-on video, it was just really, really bad. We were rushed. I was actually more focused and interested in the phone itself. Like I wasn't paying attention to the viewfinder, so I did a terrible job there. But Brian did an awesome job, like actually demoing all the features. So how do you want to do this? Do you want to go over what the phone is? You want to go through do your impressions?
sure. I mean, I want to hear your impressions as well. I think in terms of the phone itself, we should probably go through what's new, but I think we did a pretty good job calling most of what ended up being in the actual iPhone 5, minus the SoC, but we came very close there.
Yeah.
Um,
So let's save the SoC discussion for last because
yeah,
there's that's just an interesting story. So
yeah.
iPhone 5, obviously. So you said something several months ago, right? Where you listed the 3 things that you can have, and you can only pick 2 of them when it comes to putting out a product and controlling leaks about it. What was your axiom on that?
What was like, what were they? They were like
You can have
price, volume, and secrecy, I think.
yes.
And you can only really have two. And I think that just works in general. And you've seen the secrecy go away just because like the volume of these products has grown 4x, over I think it was the 4. Don't quote me on this, but I mean obviously there's been like asymptotic growth in terms of the iPhone line. So whereas you could have secrecy with the iPhone and the iPhone 3G and the 3GS and maybe the 4 to some extent, even though that was kind of a fiasco, now things have largely gone away. With the 4S and the iPads, we saw almost everything we needed to see months before. With the 4S, I mean, with the 5, we basically had the phone ready to assemble in terms of all these parts leaks like months ago. So, yeah.
And really, the only solution to that would be if Apple brought its manufacturing to the U.S. And
Well, it
controlled it
bought its
completely.
own, yeah, bought its own manufacturing.
Yeah, which is obviously cost and everything prohibitive. Um,
Yeah, it's never going to happen, right? It's never going to happen as long as they want to keep, what is it, 70% margins on these things? So, Yeah, I mean, like QED. There's nothing really else to say, right?
Okay, so what did we know? We knew the size of the display, so it goes from 3.5 inch, what is it, 960 by 640 to 4 inches, 16 by 9, 1136 by 640.
I think it was like 1116 or something. Yeah.
Yeah. So display gets taller, no wider. Um, and Apple Apple's done really a very good job about handling, all sorts of resolution changes across all of its product lines. So in this case, you have, obviously iOS 6 now supports, a taller display. You can run older apps on it. You just get black bars either around the side or the top, depending on what orientation you're holding it in. And then it shouldn't be that difficult for folks to update their apps and kind of enable support for the new resolution as well.
Yeah, and you're right. It's 1136. Yeah, I mean, part of that to me is the ecosystem is just so big now. There's no way they could make a huge change. So getting taller keeps most of that pretty much the same. And it seems like most apps now are designed to be portrait only. Like the landscape view comes as an afterthought.
Yeah.
So, extending it and just making it a big list view is pretty is I don't know, it's a pretty obvious thing to do, and it does help in a lot of use cases.
So what are your thoughts on the usability of the display? Right. So it's bigger, um,
Well,
but no
obviously there was
wider.
this great picture that got passed around that was like, oh, the thumb radius is the constraint. Remember, like everybody
Yeah.
was, and I said this too. I remember we said this, that the thumb radius constraint is something that will just magically go out the window when the iPhone needs to get bigger. And that's exactly what happened. Like it just went out the window. And the other thing is that all these people have been sort of drawing the thumb radius from the bottom corner, but that's not how you hold a phone that's this big. That's just not. You hold
Yeah.
it, like an inch up from the bottom corner. And then your thumb radius, instead of being like a quarter circle, becomes like a hemisphere, or like a half of a circle. So instead of it being this problem where I can't get to the edge because I have one radius to that corner. Now you hold it just slightly up and you can reach the corner, and the bottom corner comes with the other thumb. So there's a little bit of just people making things up, and it's we need to pass around sensationalist things because it's funny apparently. But yeah, I think you're still totally able to hold the thing.
But what about in terms of, so I'm just in love with the HTC One X. I think that display is awesome, and like you have, it's still portable, but you see so much. Where does the iPhone 5's display fall in the grand scheme of things?
I mean, obviously it isn't as large,
Yeah.
right? But it does help considerably. It's still not 720p, but I mean, I think this brings them closer to where they need to be. I don't think it's still there.
It's not, they're not still there in terms of resolution or overall size plus resolution.
Yeah, the second one, size plus resolution. But I think you could make the case that they don't really need to be, they don't really need to play too much in that space. I think people would like to see even bigger, because we're 4 inches now. It's nice to see 16:9, sort of get adopted.
Yeah.
But I think people wanted to see even bigger. Like I don't think 3.5 to 4. I don't know. It's difficult to say, but I think the people that wanted a bigger phone wanted a substantially bigger phone.
Yes.
So I
But
don't know. We'll see.
what is your take on it though, right? Like you've obviously used a lot of phones.
Yeah,
Is this
I
the
think this
sweet
is
spot for
something for
you?
an older generation. Like 4.3 inches is sort of the sweet spot for me,
Okay.
and this is still a little bit shy of that, but it's so much better than 3.5. I mean, really, when you use the One X or the Galaxy S3 or something even bigger like the Note, and then come back to the iPhone, it does feel very small. It feels like you have a very small window into your web view, the web canvas.
Yeah.
But I mean, this is a step in the right direction. And again, it's really hard for them to increase the width without massively breaking things and creating a headache.
Yeah. But so
So
I
I
want to
think
go
this will
back
stick for a
to
while.
what you just said. You said that it's definitely better, right? That it's an appreciable improvement over the 3.5 inch screen. If
Absolutely.
So it's definitely, there's this rule of thumb that, at least when you're talking about performance, that 10% of a 10% gain is that kind of the beginning of where you notice a difference. On the display side, you think that the move from 3.5 to 4, that's an appreciable, like, tangible improvement.
Yeah, and it's more because the aspect ratio change. They added this. You can now have another line of icons. You can have another line in your folders. I think most apps are just generally portrait oriented,
Yeah.
so it sort of feels bigger than it really is. And the display also got better in terms of quality, obviously. Like they talked about, they have almost full sRGB coverage.
Which is huge, right? So
Obviously,
that's on
yeah,
par with, if that actually ends up being the case, which Apple's thus far never really lied about anything like that publicly. Um, that puts it on par with what the new iPad display can do in terms of color gamut.
exactly. Yeah. So that's a big thing.
And did you
Obviously,
notice that? So
install is a big thing.
looking at the display, did you notice? I felt on the new iPad like you could really appreciate the wider color gamut. Could you see that in the limited amount of time that you played with it?
I think it did seem more vibrant. Like there are some elements of the UI, like the SMS icon, like the Safari icon that are, like immediately obvious when they change. But I mean, it's really hard to tell just how big of a visible change that is, when we only had like a couple minutes. I think, we how long were we in there? Maybe a half hour tops. I mean, like it
Yeah. Well, the
flies
video
by.
itself ended up being, I think, 7 minutes long, and you played with it more than just that. Um,
Yeah, yeah. You uploaded the video like immediately, which is why it did so well. And then I was like, I just want to keep playing with it.
yes.
And
So
so I went
okay, so
back.
you mentioned the other improvement, which is the move to an in-cell touch environment. Like, do we know the architecture? So did they embed? Are they doing transmit over the display grid?
Yeah, it's in the gating, I believe. I don't think we've necessarily confirmed it, but I think the suppliers tell you all you need to know.
Yeah.
And yeah, it's got to be in the gating.
So the do you know what the role is of that gating? Like conventionally in the display, what is the gating? What is the display gating or grading or whatever you want to call it? What is that actually used for?
Well, that's in the actual, like if you're driving your polarization crystal, which is how you sort of turn on and off the light in an LCD. Those traces are normally used for that. So they've added, I'm actually not super sure in an
Yeah.
in-cell environment whether you run the traces alongside them, like next to it, but I'm pretty certain that they use the same ones.
Yeah, no, I
So
think that's what
the
it is, right?
signaling is
Like
on there.
you already have um you already have lines that you can send something over. And then now you just use them to double up as transmit, I'm guessing, for
Yeah, that's
the
right.
field that you generate for the touch. So instead of having this like display grading down and then having the display stacked and having the touch controller stack on top of that, where you have another set of lines that run across the screen that generate a field that are picked up by another set of lines that measure the impact of your finger on the field that they create. You integrate that bottom half of the layer into the display itself, which reduces thickness. Are there any other benefits? There's obviously not an optical benefit to it too, right?
Yeah, fewer back reflections is always the gain that you get here. And so obviously there's some absorption, like everybody, like I believe he called it an ITO layer. It's just ITO, indium tin oxide. So, there's no longer this indium tin oxide layer with all these traces. And when you look at a phone and you see those like shiny squares or like shiny little lines, that's ITO, and that means that they haven't done a really good job space filling it with an index matching material. So I mean, there's all this overhead that you have to do in a normal, device that isn't Incel or the way that LCD and capacitive touches worked previously. To make that work and it still be visible and transparent and have the minimal amount of like noise in the way, like visual noise. And now most of that is gone, although you still do have to have the receive layer. And I believe that might be on the bottom of the color layer, or it might be somewhere else. These are like subtle details, but they do make a difference, and we'll find out, I'm sure, when somebody looks at it, and also who the controller is made by. Um, but yeah, I mean, you have to keep in mind each time you change index, like from glass to air, you get a 4% Fresnel reflection. I mean, obviously, when you're bonded together, they got around some of that, so they brought the reflectivity coefficient down because the index is closer. So it's pretty much still 1.5 to 1.5 versus 1.5 to 1. So glass to air versus glass to glass. But getting rid of those interfaces is the bigger gain, and that's what they've done here is remove more. Yeah, and I still don't really buy into this. Like it looks like the text is on the top thing.
Yeah.
Like everybody talks about that. I'm like, no, it's just clearly not. At least to me, I'm like, it's still an LCD. But if you want to convey that that's the sense of improvement, that's fine. But it's not.
Yeah.
I don't think I'm fooled yet. I'm not fooled. So
No, I agree. I've never really, other than the Retina MacBook Pro, where I felt like I could. That was the first time where I felt comfortable kind of using that painted on comparison.
yeah, sure.
And even then, it's clearly not. But that was the only time where I was kind of okay with using that phrasing. So did you notice any? You obviously use the phone quite a bit. You notice any change in touch response with the move to an in-cell architecture?
No. I mean, it seems the same to me. I wrote that in the little piece too. I said that there's no change, which is what you want to see. I think their touch has always been really responsive. They do a good job tracking
Yeah.
and also predicting where you're going to be. And there's not too much lag between your touch event and where you originally started, so it feels more grippy. And they've always done a good job there, so it feels the same. And that's as much of an achievement as it getting better, as far as I'm concerned, with this new move to Incel.
Yeah.
And
Now,
you know what?
so
Oh,
yeah,
sorry.
go ahead. No, go ahead.
No, what stuck out for me the most is when I picked it up, the thing felt really light, like almost like cheap. Like cheap isn't the right word. It felt like it was empty. Like I was picking up this tin box and there was nothing inside of it. And it was really disconcerting at first because, like the 4S and the 4 are quite heavy. Like they feel dense
Yeah.
and there's so much glass and metal in your, like what you're contacting with skin. And when you move to the 5, it's like it felt like an empty tin box to me. Like I tapped in the video, there's one point where I'm like tapping on the back, like to see if it's hollow, because it almost felt like there's nothing inside of it. And I saw other people writing the same thing as well. And so it's noticeably lighter. That's the big thing that stuck out for me, is that it's light almost like to a fault, which is crazy.
Do you feel that you use the word cheap? Is that how you would? I mean, does it feel like less of a product now, or was just
Maybe.
that?
I mean, I guess, yeah. Well, whether something feels expensive is sort of a function of whether it's heavy,
Yes.
right? I mean, that's sort of always existed. I mean, I
Yeah.
don't know if it feels cheap, but yeah, it feels lighter, and that has this perception or stigma that's attached to cheapness. Like the Samsung phones are always really light, and for a while, like I was writing that it just makes them feel kind of cheap.
Yeah.
And
But there's also a difference in construction material, right? They're still
sure,
using glass and aluminum here versus just some sort of a plastic.
yeah, and it's metal all on the back, and that just it felt weird. And you should note that the metal is actually dyed this time, so it's like anodized, and the edge is anodized as well, so it's not like stainless steel, at least the black model.
Hmm.
So that's a significant departure away from how the 4 and the 4S white and black models looked. So we'll see. Well, it'll be interesting to see whether it stays on. I mean, as you like scrape at it.
Yeah. So obviously, the move to Incel helped them get this thing thinner. How
Correct.
did
Yeah.
the thickness of it work? How did that feel to you?
It felt noticeably thinner. I don't know if it was like it's a night and day thing, but it did feel thinner. I think that's all you can really say about it, is that it is thinner. I don't know if it's like a huge change like night and day, but it's perceptible. Honestly, the bigger thing is when you move to an aspect ratio like this, that there's more surface area. That's sort of the aspect ratio in terms of 2D area to thickness is a big change, whereas the overall thickness didn't really change too much.
Yeah, I
Right?
gotcha.
I don't know if I'm doing a good job conveying that, but that aspect ratio changed a lot.
but it didn't feel too big, right? Like the overall phone still felt very, very portable, very
Sure. I
comfortable.
mean, yeah. Well, I'm used to carrying around bigger phones. Like you've carried around bigger phones, right? Like
Yeah,
the
yeah.
One X is huge. The Galaxy S3 is huge in comparison, but they're not like so big that you can't carry them around. Even the LG View, the Note, those are big phones, and this still isn't quite as big. So yeah,
Okay.
it's not a concern.
We're gonna get to the fun stuff here in a second. They made a lot of improvements to microphones, to noise cancellation. You have a funny story about what happened there, right?
Yeah. So actually, the biggest thing that stuck out at me was the earpiece noise cancellation. So I changed tables. I went from one table to another table, and it wasn't like the rep, like they have Apple people standing over you. And this guy really didn't know, like I hadn't been doing the video with you, and he didn't really, I just walked up. So I I started playing around with it, and I decided I wanted to do a phone call because I was like, well, this is a phone. I know the earpiece situation and the microphone situation changed. I'd like to place a phone call. So I whip out my normal device and I get the number for the ASOS that I always call. And that's the number that's published on that picture. It's not my number. It's not Anand's number. So I added a note below it to sort of stop the emails like, hey, you left your number. I'm like, it's a freely published number. So anyways, I dial this number and I start making the call and I hold the phone up to my head and like people are looking at me. Like everybody has stopped and they're staring at me. And I'm like, well, this is interesting, right? We're living in the future, and we're to the point now where me demoing a phone, actually making a phone call, not only draws suspicion, it draws ire. So I hang up that after listening to it for a little bit because I know what that sounds like. And then I decide that I'm going to do something even more daring. I'm going to call you and then ask you what it sounds like. So then I dial your number, and then of course I'm like, well, I need to make sure I delete this afterwards so that like nobody's just like calling this or like I don't want to get tracked down or anything.
Yeah.
So I call you, and then I start talking into it, and I'm like, how do I sound? Can you hear noise around me? And I don't know, how did I sound? What do you think?
I thought you sounded fine. Like it's the problem is we didn't have a control. You should have called me on like a Galaxy S3 or a One X right afterwards. Um, but
Yeah.
because the new iPhone has three mics, right, that it uses to kind of make things better.
Up from two. Yeah, that's right. And well,
Um,
remember there was the whole audience thing too. Like audience said they're not in there, but it wasn't really. It was based on they didn't see any tests from Apple that validated it. So I'm not sure whether the jury is really in or out about that one. And
yeah.
actually, funnily enough, I guess the audience people are going to be coming by Tucson next week, and
Oh,
I might
nice.
get to meet with them and ask.
That's
So
awesome.
yeah. So anyways, so I placed that call to you, and you said that I sounded okay.
Yeah.
But what really stuck out for me is there is earpiece noise cancellation. So now they added a microphone next to the earpiece, and they use that earpiece microphone in a closed loop along with, obviously what they know they're supposed to be driving on the earpiece and the two other microphone, the primary and secondary, to do cancellation of noise through the earpiece around your ear. And if you've ever put on like active noise canceling headsets, you know that there's sort of like a pressure that you feel, almost like white, not like white noise, but just like a heavy pressure. And it's because there's noise on one side of your head and not noise on the other side, and it accentuated it even more in that case. And that sensation was just very foreign to me, like very alien. And really, it stuck out for me like for 3 days after I placed that call. And so out loud, I said to you, "Oh my gosh, they're doing the earpiece noise suppression, and it's like actually working." And the Apple rep was like, "You need to stop what you're doing right now. This is making me very like nervous." I can't remember what he said, but he was like, they have this way of saying things, and it's like the genius speak. The genius speak. It's like you can't say no. You have to like I suggest that you stop doing things.
Yeah.
It's
Yeah.
like sort of like talking to a baby, or I
Yes.
don't know what the good way of characterizing it is. But he said this funny line to me that was like, "You're making me really anxious," and then I was like, "Oh crap!" and I immediately hung up.
Yeah.
You
Which is
know?
now to Apple's credit, we have been told to stop doing stuff by other companies in a far more rude manner.
Oh, that's well, like what? I can't think of anything
Do you
immediately.
not remember Mobile World Congress when we were trying to test one of the Intel phones?
Oh yeah, that's right. Well, that's really ironic, right? Because I mean, we have the best relationship with Intel, I think. I mean, well, you have a long history there,
Yeah.
and they were like, "What are you doing? Like, never come back."
Yeah,
Remember?
and
I think that's
it
what it
was
was.
it was not good. It was not good. So I feel like the Apple folks did, to their credit, they were very mature and respectful about the, hey, maybe you shouldn't be doing this right now.
Yeah,
Um,
that's what it was. That's what it was. So then I stopped.
and also the other thing is phone calls were totally okay on, I want to say, on the Verizon iPhone 4, right? When that launched, didn't I call you from a
That's
Verizon
right.
iPhone
Well, that's
4?
because it was like a big deal.
Yeah.
And they wanted to emphasize that hey, everything works. And I think the other point was that death grip was fixed,
Yes.
right? And
So yeah, that's I had no reason to warn you that, hey, maybe you shouldn't do this.
well, and
But
they talked up the earpiece noise cancellation features as well. And I think that is a big difference that normal people will perceive immediately is that there's this weird pressure sensation against my head on the earpiece,
yeah.
and that's the active noise cancellation. Like that was a
But
very noisy room.
you're describing it as a weird sensation. Is it a good thing? Do you like it?
Yes, I like that. Well, obviously, I want it more,
Yeah.
right? Like, I crave it because it was cool and it was unique and different. Like, I haven't tried another handset that has the earpiece noise cancellation turned on, and so it was neat. Like everything else, like I've seen before, right? Like LTE, okay, I've seen that for years now. Dual core, we've seen that for a while. High res screen that's over 4 inches, we've seen that for a while. 8 megapixel camera, we've seen that for a while. At least, so like I'm kind of jaded,
Yeah.
but this was like, wow, this is new. It's different. It feels really weird. So that's why it
But
stuck out.
I think that's an important improvement, right? Because a lot of folks, I know me, I'm always on the phone, right? There's some days when it's just I'm going from meeting to meeting on the phone. Uh, so it's good to see innovation there as well, right? It's good to see progress there, not just in the usual tangibles.
Absolutely. So I thought, hey, I'm going to test this out and talk about it because I just know nobody else is going to make a phone call.
Yeah.
They're just going to, browse a couple pages in Safari, thumb left and right on the home screen. And then, we got our 30 pictures, like, let's just call it a day. So, obviously we strive to do a lot more, possibly, when it's something we can.
Yeah.
And yeah, I thought that was
So
unique.
no, that's really cool. I'm really jealous. I wish like I'd experienced that. And I'm wondering, I'm hoping that they've gotten kind of earpiece quality control issues under control,
Oh,
right?
you're
Because like,
referring to the crackling and stuff?
yeah, well, because you mentioned that was a known issue on like the iPhone 4, and then I had a problem with my initial 4S, where there was just like tons of noticeable crackling
And did
when
that
I
get
talked on
fixed
it.
with a hardware swap?
See, I can't tell. I've been using it for pretty much a year now. I can't tell if I've just grown used to it or if it actually
Interesting.
got fixed. So I'm curious to see if obviously now they're focusing on making the experience with the earpiece better. I'm curious to see if that extends beyond just noise cancellation there.
I feel like that was a
Um,
shielding issue. Like it always kind of crackled for me when I had this perception that it was using the top antenna,
yeah.
and I don't know. We never really investigated that as fully as maybe we should have, or it's really hard to.
Yes.
But I felt like that was some of them lacked some shielding, or the top antenna chain would cause interference sometimes. But we'll see. I mean, hopefully it's better.
So the other big feature is obviously LTE support. Is there much to add there in terms of what folks already know? Obviously, it's MDM 9615, so 28 nanometer Qualcomm LTE single chip baseband.
Yeah, and they threw in RTR 8600, which wasn't the WTR 1605, or is it WTL 1605L? But yeah, either way, this the it's WTR. It's the 65 nanometer 5-port transceiver, and so that's kind of why you see that they have two different hardware models with different bands, and I mean
So
we talked
so
about that.
take a step back here. People kind of get what the baseband does, right? It has all the compute that, actually does all the modem work. What does the transceiver do?
Transceiver, so that's a good question. I've actually asked this question before because
Yeah.
it seems to vary a lot, but the transceiver sits in between the power amplifiers and obviously the part in the chain where you get just IQ data out. So magic happens, you have a bunch of different RF paths out, and transmit and receive, and then there's a diplexer, and that's outside the transceiver, and then what's before the transceiver is the baseband. So the baseband gets IQ data, transceiver turns magic RF stuff into just the baseband components. Um, so there's all this RF stuff that happens inside there. I suspect that's also where these interference cancellation techniques live, and like receive diversity lives.
Yeah.
And these are like features that can't be implemented in the logic process. So
Yeah,
that
they're
the
still
logic CMOS
analog.
process. Yeah, these are still analog things. So I
Except
guess
I
that's
don't
a
know.
good way to separate it. Yeah.
Did you look at the Intel Moore's Law radio announcement?
Yeah, and that's very interesting. So they did all their transceiver in digital.
Yes. Because
So
right, their
that's
their
very
whole big thing
curious.
is, you mentioned it right now. This is a 65 nanometer part. We're talking about what, two process nodes beyond that is where we're at with the digital baseband. And Intel was basically like, look, if we're gonna be, Intel really likes integration, right? Because they have to keep their fabs full. And at IDF, they're like, look, one big problem is as we scale stuff down smaller and smaller, the analog components of our RF stack, of our wireless stack, they don't scale, right? Because they're
Yeah,
still analog
very true.
components. And eventually you get to a point where, well, what happens when you're building 10 or 7 nanometer Wi-Fi or baseband, and you still have this gigantic analog block that you have to integrate? So the third day of IDF, they announced that they have now finally taken the transceiver component from an 802.11g Wi-Fi implementation and implemented that entire thing in digital logic. There's still some analog components on the outside, but they implemented it on a 32 nanometer chip, and then they later implemented that 32 nanometer transceiver in a dual core Atom SoC. So that
Yeah,
was
and
really exciting.
they talked about what's hard there a bunch of times, I think now, like the frequency domains being very close, and them having to do some like collaborative time slicing when they light up certain transceiver paths versus when they're lighting up paths on the CPU.
Yes.
So, but of course, the new Qualcomm transceiver is also 28 nanometers, but that one isn't available yet in volume apparently, and that's why we see RTR 8600 getting slotted in. And there are 1605 devices out now, like well, I guess not out now, but we've seen them before, like the Lumia 920,
Yeah.
and so I don't know that the whole like LTE band situation on the iPhone 5 is very interesting. It's a very challenging engineering problem. I still think there probably will be another model coming with TDS CDMA and maybe support for China and these other European bands. Obviously, 2.6 gigahertz needs to be supported eventually, and I think that maybe that will come with WTR 1605, like an iPhone refresh with that.
Yeah.
I don't know. I hate to speculate, but I like speculating, and that seems like the easiest path forwards. Those line
Yeah.
up quite nicely. And then of
Well,
course
this
there's
is
the Volti situation. I don't know if we want to talk about that whole thing.
Yeah, absolutely. So real quick as a recap, iPhone 5 maintains the antenna architecture of the 4S.
Yeah, and the 4 CDMA.
Yes. Now, when Phil Schiller introduced it, he said it improved upon it. Is that accurate, or is it roughly the same?
I believe it's totally the same. I don't. Did he really say improved upon it? I don't know what he's referring to there.
Yeah, I could be misquoting. There was
Huh.
obviously a lot happening at once, but I feel like he at least maybe implied that it was a newer generation of it, which is obviously likely true.
Well, I mean,
But so same
it's
thing.
improved in the sense that it has LTE now, but it's
Yes.
still the same configuration. Like they have a double pull, double throw switch, and then they can change what they can do, like a switching diversity and transmit, and they can do a switching or combine diversity in receive. So, those things are exactly how they were on the 4S. I could be wrong. I don't know. Nobody's done like a lot of testing otherwise,
Yeah.
but we'll see.
But at a high level, the hope is since receive diversity is still there, death grip issues, all that stuff that doesn't come back up. It should theoretically work at least as good as the 4S does.
Oh, absolutely, yeah.
And then obviously you add LTE, which brought a whole bunch of other debate, right? So, we were quoted in this New York Times article explaining how. So there were a bunch of. I guess, how do you want to do this? Do you want me to explain the high level and then you go in, or do you want to take it all?
I mean, you can explain it. You did a very good job in the New York Times interview. I have a tendency to get really technical and then like just on a tangent. So why don't
No.
we do that?
Well, it's not that you go on a tangent. I think it's like
I
I always
confused him. No, I definitely confused him.
you it's just you operate on a totally different plane. Like I've seen this as well with folks that are just ridiculously smart, right? Like you operate on a totally different plane than the rest of us, right? Like
Okay.
I mean, it's just you have so much knowledge about so many. That's usually how I describe you, right? When I like explain to people that you're smart, I have to explain to them that you just know a lot about everything, right? Like when I was stuck in New York, or stuck trying to fly to New York, it's I'm checking like Google or Flight Tracker, and then you go directly to the FAA, and I just have like all of the source documents on everything telling me what
Yeah,
the
I'm
weather
like, here's what
conditions.
they're looking at. Like, just
I
refresh
know.
this.
It's like I said, operating on a totally different plane. So okay, so here's the situation. You have one transmit chain on the iPhone 4S, on the iPhone 5, and since voice over LTE is not currently supported, right? You can't transact voice over LTE; it's just for data. You have a fallback mode on, for example, the GSM, the AT&T iPhone 5, where once you start transacting voice, you actually fall back from LTE to HSPA plus or whatever traditional 3G. And on the AT&T devices, that's fine because you can transact voice and data at the same time. There, you have one transmit chain, so everything works the same way it did on the iPhone 4S. It just happens to be if you're making a voice call while you're transacting data, you're not going to get the same LTE speeds that you would when the call ends. And I'm really curious to see how that whole handoff works, right? Because in my experience, I didn't do too much work at the 28 nanometer side, but when I've been testing AT&T LTE, I've always had weird issues with not getting back on LTE so quickly after making a call, or just a bunch of really silly stuff happening there. I don't know if your experience mirrors mine at all.
Yeah, that's an unsolved problem. And actually, when I was at Qualcomm talking with their modem people, I had a long discussion about that. And really, it just comes down to, comes down to the software that's running on the base stations, so your ISVs, um, and that whole collaboration, and it will get better. Like for me, the number of times that I've been in LTE markets and done a call and then waited, it generally happens pretty fast, at least for me. Like initially, it was a big thing. I think on Verizon, it was really a big problem initially. Both I remember handovers taking seconds between LTE base stations while driving around. Like back when I did our initial LTE testing, and it was on MDM 9600 with the dongle and then the Thunderbolt. And yeah, the handovers were like in seconds, and that's improved now, and handovers are faster. And then the hand up to the hard hand up from WCDMA 3G to LTE has gotten a lot faster. And I mean, honestly, we'll see how well it does in here. I think that obviously Apple does a really, really good job generally with engineering that side of things. So their stack is, again, this is another part of the discussion, is that the stack is really simplified because they don't have to worry about um, yeah, SVLTE for the EVDO devices. So they don't have to worry about simultaneous voice and data because it doesn't exist
Yeah.
for the
So
CDMA phones.
So that brings us to the controversial part of the story, right? Which is on the Verizon phone, again, one transmit chain. So you're transacting data over LTE, you get a phone call. You stop transacting data over LTE because you obviously have to fall back to something. The issue is you fall back to EVDO, or you fall back to 1X RTT, right? Where
That's
all
right.
voice is handled. And there's no support for simultaneous voice and data there, right? Because there's only one transmit chain, so all you get is voice at that point. You stop transacting all data, um, and that's what caused a little bit of an uproar because you had, I guess, a previous generation of devices. So this is Apple's first LTE implementation, right? And they obviously they wanted to keep things as kind of consistent and as uniform across all devices. So you have one transmit chain across, both their AT&T devices, Verizon, Sprint, so on and so forth. So on the Verizon and Sprint devices, when you fall back into a state where you can't transact both voice and data at the same time. By comparison, you have all of the folks who did, back to when LTE was a discrete chip, right? In addition to your EVDO baseband, folks that designed phones around that had to do two transmit chains, and they kind of enabled simultaneous data and voice on LTE by kind of continuing to transact data on LTE and simply using the other transmit chain to deal with voice on the 1X and EVDO baseband.
Exactly. Yeah.
And it sounds like those guys, so Samsung supports it. Is that correct?
Well, and see, it's even more subtle than that because the new single baseband devices like the One X, or I guess the Evo 4G LTE, and the Galaxy S3 on Verizon, or even the Evo 4G LTE, those all have the same MDM 9615 IP block inside 8960, but they have the ability to do, this single radio, simultaneous voice and data configuration with LTE and EVDO and 1X at the same time. But they still have two transmit paths that are discrete. So it's just, and that's the de facto way of doing it on all these other phones. So of course, when the iPhone comes around and they chose to implement things differently, that simultaneous capability has gone away, and hence the status quo is sort of broken of this being the way to do things on every LTE phone for Verizon or Sprint, and hence the uproar. And yeah, there we are. So
But what's your take on that, right? Like, so obviously from Apple's perspective, the one solution is you implement another transmit path for the Verizon device.
right.
And obviously you have to cram that antenna in somewhere.
Yes. So I
Perhaps
mean, like,
change.
I don't know where they would have put it, but I mean, it obviously could have been engineered in there. At the same time, there's no easy way to do it without breaking this consistency between the two. And
Yeah.
there's already two different models. There's A1428 and there's A1429. And A1428 is for, AT&T slash Rogers and it's a couple other places. And the A1429 device is more of the global, like the handset that's going to ship a lot more of, and that one also works on Verizon. So when I look at it, I see like an engineering decision that was done to both consolidate the lineup, you know, make as few devices as possible, which has always been Apple's MO, and then you know, just like everybody sort of needs to deal with it, and then the same thing. Even when I mean everybody needs to deal with it, I mean because there, if you were on a Verizon iPhone 4 or 4S, you already didn't have simultaneous voice and data. So from their perspective, because obviously they're only really concerned with what the upgrade path is there, this is the same experience, if not better, because now you have LTE in addition to EVDO, if that makes any sense.
Yeah, no, it does. And so kind of the long-term solution is we eventually get voice over LTE,
Right.
which from what I understand talking to you, you're looking at another 12 to 24 months before we start seeing voice over LTE devices hit? Or
Yeah,
is that
that's still
for
a ways out. I mean, the carriers need to fully test and implement all of that, and then that gets deployed, and then we see handsets start arriving. So yeah, I mean, we're looking at like late 2013. It really depends. Depends on how fast all of that goes. But I mean, the carriers like to move glacially slow, internationally, there's some VoLTE, like VoLTE.
Yeah.
Um, Actually, I was kind of playing around. I believe the LGU Plus network, which is what I'm on here, that one is VoLTE enabled. So like I placed a call on that and it worked fine. Um, so eventually that will come to the US. And I think a lot of people, like a lot of people have been emailing asking, well, will the iPhone then support VoLTE? And I don't see why it couldn't be possible with an update. It would require, a lot of re-engineering, obviously of the baseband software, of the handset to enable it, and then another trip through the FCC. But I mean, we are talking about a device that's going to have a big attach rate, a lot of importance, for the carriers in terms of their like their use expectations and what perceptions get set. So I wouldn't say it's impossible. I'd say it's unlikely. I'd say that you shouldn't buy something based on like a maybe it will support this eventually
Yeah.
feature. That's just terrible advice for me to give. So I mean, it's possible, but it's not confirmed at all. Like I emailed AT&T, I emailed Verizon asking for what their official word was, and both of them said they have no plans to announce. They have no official information. I don't believe we got a statement back from Apple.
No, nothing
Um,
from Apple yet on it, but Apple's been kind of busy putting out
yeah,
fires this past
exactly.
week.
So we'll see. We'll see. I mean, Verizon completed its first successful voice over LTE call um, a while ago, and we'll see what happens. That's all that I
Okay.
can really say.
So we went through network, and then that brings us to the kind of one surprise in
Big
all of this.
surprise.
Yeah, the big surprise, which is the SoC. So for a long time there, let's take a step back. Let's look at Retina iPad, A5X. You Apple did a super wide memory controller, 128 bits wide. So actually on par in terms of number of pins dedicated to memory I/O as what you have in your Core i7 notebook. Huge memory controller, huge GPU, PowerVR SGX 543 MP4, so twice the GPU compute power of what's in the iPhone 4S, significantly faster than any other mobile SoC that's shipping today. So Apple builds this thing and they put it on Samsung's 45 nanometer low power process, and it makes the chip huge. Right, it's something like 163 square millimeters, so it's
Yeah.
like it's bigger than a dual core Ivy Bridge.
And it's not a pop either.
Yeah, it's not a, I mean, I don't know that you could easily
There's no
do
way.
a
Yeah.
pop stack with that many IO, with that much memory IO. So Apple releases this chip, and it's beefy, it's fast, but obviously this is not going into a phone. Shortly thereafter, we see this other 32 nanometer A5 derivative, right? So A5R2 is what we've been calling it publicly, and it's just a bona fide die shrink. We found it in the iPad 2.4, which Brian needs to take all the credit for this, because as soon as Apple announced, the kind of cheaper iPad, Brian was on this like march. We have to get one of these. We have to get one of these. I bet you there's different silicon in it, and
Yeah,
lo and
but everybody
behold,
was like, no, that doesn't exist.
yeah.
We don't know.
So lo and behold, we eventually get an iPad 2.4, 2.4 is their internal nomenclature for it. And yeah, it's got 32 nanometer A5 silicon in it. Now, not all 399 iPad 2s have this A5R2 in it. Some have just a vanilla 45 nanometer A5. They both perform the same clock, same feature set, everything. But if you're lucky, you would get this iPad 2.4 with 32 nanometer silicon in it. And at the time, we looked at it as, well, this is unique, right? A die shrink is very rare in the industry these days. Normally, now you go to a new process, you add some more transistors, you improve performance. So at the time, it looked like this is what Apple was doing, was just testing Samsung for volume, right?
Right.
This was their pipe cleaner chip. They send this through to make sure that they got all the kinks worked out, because they're going to be deploying something that's much higher volume later on. And then it all makes sense, right? You go 45 nanometer on A5 because you can get good pricing on the wafers because it'll do the volume you need. But you have to produce something. You need a test chip at 32 nanometer at Samsung to make sure that you're going to be able to hit good yields and good volume when the time comes. Now, you can always, you do test silicon, right? Like you put a bunch of gates and memory and all this other stuff. You build these chips that serve functions, but there's a huge difference between building a test chip with a bunch of gates on it and building a fully functional SoC. So there's always this balance of, you learn a lot by building a huge chip that's very complicated on a new process, but at the same time, there are going to be bugs, there are going to be yield issues. So if you make it too big of a chip, then you're not going to be able to have many useful die in the market. You make it too small, you won't expose any of the weird issues that you're going to encounter with the production on the new process, and you'll end up with very little learnings. And unfortunately, when you go to market with something that is more complex, you'll have a lot of yield issues. So it's like this really careful balance you have to pick in what you choose to be your pipe cleaner or your chip to start on a new process. So Apple picked A5, a chip that they'd been very, very comfortable with, experienced with, and they did a straight die shrink of it, put it on 32. Then they've been shipping that for a while. So Brian, you and I both thought that, hey, look, what's going to happen is we're just going to see A5R2 at higher clocks in the iPhone 5, and then next year with the iPad 4, we'll get new architecture, maybe go to Cortex A15, and stuff will get more interesting by then.
Because that's been the normal cadence. And then we also saw, the Apple TV uses that same SoC, but with a core disabled. So it was like, well, even the ones that didn't perform as well, they're still using. But I mean, now it's so obvious, right? Like it wound up in the iPod Touch. Yeah.
No, it's so that was the thing that we didn't think of, right? So at the time, it made total sense, right? The chips that are functional, you throw in iPad 2s. If you can't make enough, you still have a supply of 45 nanometer A5s that you can throw in iPad 2s. The chips that maybe just one CPU core doesn't work, disable it, throw it in an Apple TV. No one's going to complain there if volume isn't what you need it to be. And we weren't even thinking about the iPod Touch. Right now, It makes total sense that this chip just goes into the new iPod Touch and something new entirely comes for the new iPhone. And, so a few days before the event, we start getting information that's coming in saying that, look, this is not just vanilla A9s, but something much bigger and better altogether. And I start thinking about it, and, you and I start talking about it, and it makes a lot of sense, right? So if you're not going to do A9s, Apple has, even though they have a good set of CPU architects internally now, they've always just licensed an ARM core. So it was ARM 11, then it was Cortex A8, then it was Cortex A9. And the logical conclusion is, well, if they're using something that's bigger and better than an A9, then it has to be Cortex A15, which for so long we said was just unbelievable, right? Because Samsung and TI in particular, these are launch partners for ARM, and they're not shipping them yet. So for Apple to kind of come out with
they don't even have final clocks yet. Like we're not even still at what they said their final clocks would be.
Yeah. So for Apple to just come out and one up them just seemed too good to be true, right? It seemed unusual. And so, I made this claim initially that, look, the A6 wasn't just higher clocked A9s, wasn't higher clocked Cortex A9s. And the justification there is pretty simple, right? So, and I referenced this when we did the updated A6 analysis post. But basically, you have, when you design a microprocessor architecture, you have kind of a target frequency. And you can go above that frequency and below that frequency. You can scale up and down by kind of playing with the voltage. So you increase voltage, you can go higher frequency. Decrease voltage, you can go lower frequency. In a power-constrained environment, where power matters, you want to be as close to Vmin, so at minimum operating voltage as possible. The reason there is you have this kind of exponential relationship between power and voltage, whereas it's a linear relationship between power and frequency. You start having to dial up voltage to get that frequency, and power goes up much more than you'd like it to. Intel kind of encountered this back in the Pentium 4 days, right, where you had, they kept scaling frequency. Right, that was their only vector for improving performance, and eventually, it allowed AMD to kind of surpass them in terms of performance and power efficiency. So, it sort of makes sense that Apple wouldn't want to just increase or double frequency of the Cortex A9 to get the added performance they wanted. Right, so Apple announced a 2x increase in performance. You can obviously get there. The old A9s in the A5 SoC only ran at 800 megahertz. run them at 1.6 and you'll be fine. The issue is, and the reason that doesn't work, is Apple also claimed improvement in battery life. So the move to 32 nanometer will give you better power consumption characteristics, but it won't give you 2x performance and better power characteristics. And that's kind of what Apple promised, right? So that was off the table. Then the more you and I talked about it, right? A15s didn't make sense because that's a deeper pipe. That's a much more power hungry part than the Cortex A9 was.
And it's designed for servers, as we like pointing out.
Yeah, like it was the initial target for the Cortex A15 wasn't a phone, which is part of why, obviously it's going to make it into phones, but this is a very power hungry architecture. So if it's not an A15 and it's not an A9, what could it be? And I did a lot of legwork and talking to folks and trying to get an understanding of what this is. And then eventually it came through that, hey, this is a custom Apple design, right? So it's implementing the ARM v7 instruction set, but it's not an A9 and it's not an A15. It's not IP that's licensed from ARM. The only thing that's licensed from ARM, I'm assuming here, is the instruction set.
That's right.
And everything else, or components of everything else, are designed by Apple's own internal CPU team, which leaves a whole other set of questions on the table, right? We don't know anything about the way the chip looks, about the architecture, and I am not counting on Apple sending us a nice block diagram of this thing.
Yeah, that's never going to happen. Well, I mean, you pointed out too, the other thing was that Apple has never ever confirmed even that, like the A5 was an A9 or the A4 was an A8, or, just back in history, that's never happened. So for this to change the number in a major way meant that it needed to be a different CPU architecture, and that the logical extension was A15s, which backed up what your sources told you.
Yeah, exactly.
And of course, I'm like, yeah, that makes sense. And obviously it can't just be another A9 with those claims.
Yeah. So then today, we saw the first, and I'm sure you've been doing the same. I've been religiously checking Geekbench to see,
I was refreshing 5,1 and ended up being a 5,2, which is interesting to me because that says it's probably the A1429 model as opposed to A1428 that somebody, clicked upload on. I guess as somebody who was pre-sampled. So we're not pre-sampled, so it's not like we leaked it to ourselves. But
yeah, so someone who has likely a Verizon iPhone 5, either a reviewer or someone in the supply chain, because these things I'm assuming are now starting to float around carriers as well.
True.
So someone there ran Geekbench 2 and they tapped upload, which, assuming they didn't fake this thing, gave us a wealth of information, right? So it gave us clock speeds, which is a gigahertz. So a 25% increase from where the previous silicon was running. And that kind of confirms the whole, this isn't just higher clocked A9s, because from a 25% CPU increase in CPU frequency, you can't get a 2x increase in performance. And we got a lot of information from it, right? So that tells us...
We got confirmation of memory too, which we talked about the day before.
Yes. So you dug up the Samsung part numbers, which ended up being what? A gig of RAM?
That's right. Yeah, two devices, dual channel, 1066 megahertz, 1.2 volt LPDDR2, and you did the math out, and that's 8.5 gigs per second.
Yes. So, and there's nothing too earth-shattering there, right? So it's more memory bandwidth than the iPhone 4S, obviously substantially less than the 12.8 gigs a second you get on an iPad 3. But memory is kind of an interesting thing in all of this, because it's kind of widely known amongst the industry that the Cortex A9 never had a really good, the core itself was good. All the compute in the A9 was actually, remarkably competitive. Everything beyond that, right? The once you start getting out away from registers and start accessing caches and memory, that it just actually wasn't all that great of an architecture. And if you look at the Geekbench results that came out, you see huge improvements, right? You see somewhere from 1.7 to, what is it, 5 plus X?
Yeah, I think there was one that was 6 or 7. There was one memory test that was 7X, yeah.
Huge increases in memory performance over the iPhone 4S. And it's really that enables a lot of the performance gains, right? Then you start looking at the gains in compute that we're seeing here. And across the board in all of the integer tests, you're looking at 2.2x. Is what we saw on average. You go to floating point and then you're looking at 1.7 to almost 5x increases there. I think a lot are around 4x. And then all of that, some people were surprised and they were saying that, look, well, this means the iPhone 5 is actually faster than the 2x claims that Apple promised at the event compared to the iPhone 4S. You have to remember that Geekbench is like, these are low level CPU tests. A lot of this stuff fits well in cache. Like, it's not representative of overall application performance. But that being said, we're still, the numbers that Apple shared were still 1.7, 1.9, 2x performance in application level tests. So whatever this architecture is, from
pretty good.
From a 200 megahertz increase in performance, that's pretty impressive.
Well, I remember the speculation then was that if it's not using an if it's not using an A9, it's not using an A15, then what are the clocks? And then that will tell us how good this architecture is in terms of IPC over an A9.
Yeah, so
right?
that obviously...
That was the other guess, is that it had to be two 1.6 gigahertz A9s, which isn't entirely impossible. Like, Samsung puts their A9s there. So that was a totally valid also guess.
Yes. So I don't know. I mean, it's really interesting. Like, this puts Apple in a completely different position now, right? Because obviously the positive side is they can tune the architecture for exactly the device that they're trying to release. They know the OS release schedule, they know the device release schedule, and now they can tune architectures to kind of hit perfectly. And you saw this firsthand, right? So you've been using the iOS 6 beta, and you've been using flyover mode on maps, and the new iOS 6 maps, and you were shocked at how much faster they are on the iPhone 5 now.
Yeah, it was substantially improved. I mean, well, and then didn't I pull it out in front of you, the 4S?
Yes.
I do that, and you were like, oh, this is awful. Like, now it looks awful. I mean, previously it didn't look that awful, but I mean, when you're doing both of them side by side,
yeah,
it's just night and day. Like, honestly, the 3D flyover maps on the 5 is like 60 FPS solid, even when it's loading buildings, even when you're doing, the level of detail changes, which, is going to incur a lot of texture swapping and geometry swapping. It was like fluid, whereas that just drops substantially on the 4S.
Yeah. So I think, that's an application that obviously really stressed the memory subsystem. And that's something that clearly, if these Geekbench results are accurate, it looks like Apple, went in and addressed. So that's the positive side of all of this. The negative side is, and, I keep mentioning this whenever we talk, is that all processors have errata, right? All processors have bugs. And some of them matter and some of them don't. And now we really, like, the discussion now shifts from, hey, Apple knows when to integrate good IP, to now we get to see how good Apple's QA and validation teams are, right? Because validating complex silicon isn't easy. You look at, I guess the most recent example of that in the x86 space was the first Phenom from AMD, where they had that TLB bug that didn't impact a lot of people, but it could cause issues for certain workloads. And they had to ship a bunch of systems with that feature disabled, which impacted performance considerably, right? And obviously the famous one is Intel's FDiv bug with the original Pentium. And I always have this kind of internal rule of thumb is in that your validation, you look at validation and you look at QA completely differently once you've had one of those issues.
Yeah, so we were hoping that the issue that would fix Apple QA was the antenna gate / death grip thing.
Yes.
But you were saying that's probably not big enough?
Well, it's just totally different, right?
Crate had an errata too, right? Like, we've sort of talked about this. Like, if you know me in person, I've talked about this, but the Crate errata 26, 1.15 volt min thing, which it actually gets spit out during kernel boot, like they check for it and set the voltage minimum equivalently. But I mean, even that, that's fixed now if you buy an 8960. But yeah, nobody's immune. So obviously you're spot on. So it'll be an interesting little Easter egg hunt to see whether there are any.
Yeah, and like I said, all processors have them. the question is, we know nothing about this kind of internal team here, right? Obviously, Apple's been hiring a lot of really cool folks to work on these chips. But and it's interesting when they did that whole kind of in response to the AntennaGate thing, they toured their antenna testing facilities and stuff like that, which all seemed like really, really top notch.
Sure,
So
I mean, they did the song and dance or the pony show or whatever. I mean, we weren't there, um, but ultimately, yeah, that came down to like industrial design versus is it going to work in the realm of physics, you know?
yeah,
So hopefully, when you're engineering a CPU, this is entirely engineering driven. So at least that sort of stuff won't happen where it's like the CPU doesn't look pretty, so we need to just make it not work nearly as good.
yeah. Well, so it's interesting. The potential upside here is huge, and obviously we'll find out more here in about a week when we get our hands on devices. Um, which I'm still kind of. It is still really cool that we are talking about very short leads between announcement and availability, right? Like it's we kind of take that for granted on the PC side. It used to be that you would announce a GPU and then like a month and a half later the cards would be available. But now, everyone's kind of moved to this, look, NDA lifts and you have stuff available right away.
Sure,
So
yeah.
it is cool that Apple is kind of headed in that direction and has been maintaining that policy for a little while now.
Well, they've built out just, I mean, this is part of the magic of their ecosystem is that they know exactly when to deliver, when to strike when the iron is hot. All those aphorisms really are true. I mean, when you're at the top of your hype cycle, I mean, you've just done a PR thing. The whole point is to get people excited,
Yeah.
right? So obviously, make it available, make it possible to make that expenditure right then. And so many companies still don't do that, like in the phone space or elsewhere. And at the same time, I wonder if they're going to keep doing that because obviously the other side effect is they've been building up stock of these things, and that's where the leaks come from is just huge volume, building up a stock of these things, getting everything right. Um, so I mean, who knows? Maybe that goes away, right?
So it goes away in that.
All of a sudden, you have like a month lead time between when things get announced and then availability, as opposed to like a week.
Yeah. I mean, I hope not. I like this.
Yeah, well, I like this too, but I'm just saying that's really where you see Apple leaks happen is because this thing has been in manufacture for months now, like in mass.
Yeah, exactly. Oh, because you have to test it, right? So you have to
Exactly.
make it to test it, and then I'm really curious to see because once you start going to like this level of custom silicon here, that impacts everything, right? Like it's there's not a second supplier of this stuff now, right? Like there's no that design is your design, and I don't know how many revs it's gone through, right? Like how manufacturable it is. Like there are a whole bunch of new variables here. It's just a totally different game at this point, and I'm really curious to see where things go from now. Um,
Yeah, whether it just the iPad 4, I guess, model gets just a higher clock, or whether it's something else entirely, or whether they separate what silicon goes into iPhone versus iPad.
Yeah, I mean, well, so the one thing we didn't talk about is GPU.
Yeah.
So we confirmed, you mentioned we confirmed on the memory side two 32-bit LPDDR2 channels, 1066 data rate across them. And the common thinking at this point, because they're promising a 2x increase in GPU speed as well, up to 2x. So the options there are we had a 543 MP2 last time in the A5, 543 MP4 in the A5X. The latter doesn't seem to make sense, right? Because the issue is when you're designing an SoC, your die area is defined by how much I/O you have around the chip, right? So if you have, that's kind of what defined the die size of the A5X. They needed 128-bit memory interface, which meant they had a lot of die space to work with, and thus you integrated 4 or 543 GPU cores in there. Here, with only a 128-bit wide or 64-bit wide interface, you don't have as much room, and we're kind of thinking that it's this intermediate point, right, where you have a 543 MP3 in there running at kind of higher clocks.
Yeah, and that is sort of weird to think about because I guess, I mean, even we weren't initially thinking that it would go in anything but powers of two,
Yes.
right? Like three is just an odd number, and I still people are like, "Did you type that right? Like MP3, like the audio file?" You know?
But yeah, everything we've heard thus far from good places, and it sucks. Like, I hate that we can't be more specific about this stuff, but that's the catch-22, right? Like, the only reason we know it is because we can't be specific about it.
Exactly.
And even now, like, a lot of stuff, most stuff that crosses our desks, like, we don't talk about. Period. This is just a very, very unique situation in that, Apple just doesn't talk about these types of things. So we do have to share some of it. But yeah, everything you and I have heard thus far points to 543 MP3 running at slightly higher frequencies, which makes sense. Again, you could take an MP2, run it at twice the clocks, and get 2x the performance. But then you run into that trade-off of voltage versus power. Whereas if you're okay with spending a little bit more on the die area, you can run closer to lower voltages, and thus you get kind of better active power, which obviously matters a lot in a phone. So that's the iPhone 5.
Yep.
And
It doesn't sound like a lot when you look at it at a high level, but I guess it is a lot. So
I mean, it's a lot
it's a
because
big step forward.
you have to think the number of folks that have to work on every component here, right? And this is what is kind of
Oh, and don't forget
I've
dual band Wi-Fi. Oh my gosh, dual band
yes.
Wi-Fi! Finally, thank God.
Do you know? We don't know if you'll have 5 gigahertz Wi-Fi tethering though.
No, no, we already do. It does not have 5 gigahertz Wi-Fi tethering from the
What?
FCC docs. Yeah, not supported.
Okay. Why is that? Why does no one support that?
I don't know, just a decision. I honestly don't. There's no reason why it couldn't. It's probably just the driver, host AP or whatever. Broadcom doesn't
That's
have it
really annoying
supported.
to
I've
me
never
because
seen it
that's
enabled
one of
ever.
the things. Yeah, exactly. That's one of the things that would be super useful. But whatever. So yeah, like I was saying, the thing that I've really grown to appreciate about all these companies is you look at what has to happen, right? So you have a team that's responsible for getting this in-touch display to work. You have a team that's responsible for integrating LTE. You have the OS team. You have a team that's responsible for the A6. And even within the A6, you have a team that's designing a brand new CPU core, a team that's working on the memory controller, the new ISP, right? You have a team that's working on integrating the graphics controller. And all of these teams, full of very smart people who run into very big issues, they all have to coordinate and deliver a product that ships at the same time.
Yearly, yeah.
Right? Like, it's not like, well, hey, we ran into a problem with, hey, our A6 doesn't work as well as we thought it would. We'll need another 3 weeks. Like, that doesn't fly. Everyone has to be ready because we have to be in stores September 21st. So you guys have to be done with your work 3 months prior. And then everything that happens, and everyone has to be done with their work at the exact same time. And it's like this across the industry, right? Like, you look at designing a CPU, you have, there's not, these things are way too big and way too complex for one guy to own everything now, right? So you have a guy working on some FPU unit somewhere, and you have another guy working on an out of order component, like an execution or a scheduling window or something like that. And all of these folks have to do their completely different tasks and just ship a product on the exact same day, which is unfathomable to me, right? Like, I look at how hard it is to get, just a bunch of folks working on different things to kind of all stay in sync. And we're talking about hundreds of engineers working on completely different areas of a design. And I don't know, it's always been really impressive to me.
Yeah, I mean, obviously there's just so much that can go wrong here that it's amazing always that it even comes out. So we didn't
And
talk too much about camera, but I think, the camera thing, it didn't really, like, even though the specs didn't improve, the system got thinner, just like we said it would. So that's interesting too. And there's the sapphire window thingy, which is pretty cool.
and they're
But
doing
yeah,
do you have any insight into what they're doing? They said they have like much better low light performance by some weird combining of pixel data.
yeah, they said they computationally combine a couple exposures and then you just get you can, I mean, you can do this, right? Like it's sort of, instead of binning in space, you're binning in time. So they must do that. I don't know how they get around the shakes. They must They must just integrate and then use the same sort of edge detection and merge functionality that they do with the HDR, because they
Yeah.
actually do some feature extraction and then piece the images back together carefully, so that the same features line up. So I suspect that they've used some of what they've learned there to do the multiple exposure combination for, low light.
Yeah.
And I didn't realize it initially, but the Panorama app works on the 4S too. So the Panorama comes to the 4S as well.
Oh, cool. And you tested that feature. That worked really well and quick.
Yeah, it works really well. It works well on the 4S too. So that's pretty much done in software then. So yeah, they seem to be doing, a really good implementation that isn't just you take three different exposures at different field of view and then, match them up. They take like a little, like I think it's a 16 pixel block. There's some block that they sort of take a strip of and then integrate over, which is the right way to do things because it's much, smoother and there's less craziness at the edges. So yeah, I tested on the 4S and it looks great as well.
Cool. Um, so yeah, that's iPhone 5 comes out September 21st. You're flying back the day it comes out, right?
Yeah, so I should get home and then it should be there. I did the mail option. I,
Okay.
you're flying to New York, right? That day?
No, so I'm in New York. I fly to New
Oh,
York
okay.
tomorrow, right? No, what day? Well, so this will air on Monday. So yeah, the day after Monday. So on Tuesday I fly to New York. I'll get back the night it comes in. And then there's just, I guess we just go straight to work on it.
Yeah, that'll be fun. We'll see how
Yeah.
that works out. You got yours on AT&T, right?
Yes.
Same. That's what I did.
Yeah. A lot of folks, I think, after all the voice LTE stuff happened on Verizon, I had a lot of emails from people saying that they wish they knew about that earlier and they would have switched to AT&T as a result.
Really?
Yeah, no, it was actually a lot of folks on our server team, like John,
Seriously?
and
Wow.
yeah, they were just like, oh man, it's that was enough for them to want to switch.
Well, that's for them. They probably want to be, if they're on the call and something's down, they
Yes,
want to be able to go and reload it and test or have console. So, yeah, that's a good point. I mean, this is like if you have a use case that definitely depends on it, then it's really unfortunate, but you're SOL here,
yeah, and
at
I think
least
the other
until
thing
VoLTE.
is, AT&T just isn't as bad as it used to be here.
Yeah, they still have a huge stigma attached, sadly, but it's gotten a lot better.
Yeah. There's still times when I agree completely unusable, and I'll regret saying this come CES next year, but
Oh God,
yeah,
you see, I miss the old CES when like 2 years ago when LTE was brand new, and you
yes,
had to be like a who's who to have an LTE dongle because it was like flawless.
yeah,
And the same with this last CES with AT&T LTE because AT&T LTE had just started, and it
yep,
was like flawless. Like you could do 20 megabits on the show floor. And I know that
yeah,
this
that's
year it's just going to be unworkable, like just
no,
back to literally not being able to do anything.
yeah, it's gonna be terrible again. Um, so I wanted to talk about Haswell a bit. We are running kind of long here. Maybe we save a lot of the Haswell discussion for next time. We can get Ian back on as well.
That would be cool. Yeah, I think that makes sense.
Yeah, and then that'll give me time. Like it'll give us stuff to talk about because I'll have the Haswell architecture piece is, I would say, probably 40% of the way done at this point. I need a good couple of days of writing on it. I mean, at a high level, so Haswell is really interesting. I'll kind of give you a teaser here. So there, Haswell really plays potentially three roles in the world. As far as desktop users are concerned, as far as if you have a normal sized notebook, Haswell is just kind of a better version of what we have right now with Ivy Bridge. So it's still 22 nanometer, but it's a TOC. You kind of get more execution resources. You have FMA support, so better floating point performance. You have much better bandwidth on the chip itself. Obviously, much better graphics performance as well. So everything kind of gets better. Power consumption will actually drop a little bit at the platform level. Even for desktop stuff like that. So there's some improvements there, but that is largely evolutionary. Then there's Haswell's other side, right? So Haswell ULT or Haswell U. It's basically the ultra low volt part that'll go into Ultrabooks, MacBook Air, all those kinds of devices. So those parts get really interesting because when you implement one of them, you don't just it's one, you get a single chip solution, so it's a full-blown SoC now. Whereas for desktops and traditional notebooks, even today, you have the CPU and the PCH. Like the PCH handles like all of your SATA and all of that. ULT Haswell, single chip, just like you would get in a tablet or a smartphone.
Wow, so they have all the I/O on their SoC then.
Yep, it is a single chip.
That part. That's
yeah,
awesome.
so it's so that's where Haswell's a bit different, right? You get a single chip, integrated graphics. There's this whole discussion about them doing also some unpackaged DRAM for better performance as well, although Intel hasn't publicly confirmed that yet. And then all the I/O is on there as well. So you get the single chip solution, but it doesn't end there. So if you implement one of these Ultrabook class Haswells, Intel actually also goes in and specs the rest of the platform for you. So they go in and spec other microcontrollers, they spec voltage regulators. That part, the single chip part, also integrates some of the VR stages. Some of the voltage regulator stages are actually moved onto the chip itself. So Intel specs the whole platform at that point. Obviously, you still get components from third parties, but they're components that Intel has worked with and understands, and so on and so forth. And they're all optimized for power. And what they do is when you have this kind of Haswell U, Haswell ULT platform, you now enable this new set of sleep states. So traditionally, if your system is up and running, you're kind of working in what the ACPI spec calls S0. So you're not asleep, everything's running at full speed. If you shut the lid on it, you typically these days you go into what's known as S3 or suspended RAM. In these Haswell ULT parts, you stop going to S3. You instead go into a new set of sleep states that are defined as S0IX, where the X can be a number of like 1, 2, 3, whatever. And in these states, the entire platform actually is constantly trying to go to sleep. And it can just wake up really, really quickly to fetch new data, get IMs, get tweets, so on and so forth. The whole platform ends up performing a lot like a smartphone or a tablet. That's actually where this was inspired from. Like the whole S0IX set of sleep states was first debuted in Moorestown. And you only get that with this Haswell U, Haswell ULT platform. And it's with that you get this up to 20x reduction in idle platform power, which is huge, right? That gives you potentially much, much longer battery life while your system's still up and running and doing useful things. So that's the kind of secondary role of Haswell. The third role of Haswell, which is not very well defined right now. So Haswell ULT starts at 10 watts, down from 17 in Ivy Bridge. And that power savings is not only through architecture changes, through integrated voltage regulators, through all of that, but it's also through these platform level advancements. Right, so Intel gave an example where there was this one microcontroller they found a lot of OEMs using, and through a firmware change, they went from 30 milliwatts of power consumption down to 5. So it's really stuff like that, right? Like just pushing the OEMs to say, hey, look, you have to pay attention to everything in the system now. So the third category of Haswell is kind of undefined. It doesn't have a name that we can say publicly yet. But Intel hinted at it, and they said, Haswell could, as an architecture, go below 10 watts. And in their demo at IDF, they had it running Unigen and consuming somewhere between 7 to 8 watts, so the whole SoC. And the kind of implication there, and obviously Intel didn't say a lot of stuff about this, but they were like, look, once you get below 10 watts and you start talking 7 or 8 watts, which is what they're demoing today, which means they could go lower in the future, that's low enough for you to get into some interesting form factors. And when I say interesting, I'm talking...
Yeah, you don't need to skirt around saying a tablet or a smartphone or something.
Exactly, right? So you're talking not phone yet, but definitely tablet.
Yeah.
And not just any tablet. You're talking, this is not far off of where ARM is. So that's kind of interesting. I don't expect that we'll see those types of Haswell platforms until the end of next year at the earliest. But that'll be the starting point. And then you add on what Broadwell brings. So a shrink to 14 nanometer, where you can cut power down even more. And now we start getting into some really, really interesting use cases where you can get into very tiny devices, very power constrained devices with top tier, Intel's Core series architecture. You're not talking Atom anymore at this point. So a lot of really cool stuff happens around Haswell, and it's finally all beginning to click. The other thing that the kind of epiphany that hit when we were going through all this A6 stuff was that if Haswell goes into single digit power consumption, and if that's where Ultrabooks head, right? If that's where the Ultrabooks and let's say the MacBook Air line go towards, then we're also in striking distance of ARM cores kind of being able to fit into those same power envelopes, right? When this rumor came out that Apple was thinking about ditching Intel, it never made sense to me because I always looked at Intel's role in Apple's lineup as 35 to 45 watts.
Yeah.
But if we're talking like sub 10 watts, and if A6 is really as good as it seems to be, compared to other ARM architectures, and if Apple is able to continue iterating along that, I can definitely now see a path to Apple having maybe not a MacBook Air, but something MacBook Air-like, driven by ARM silicon. I don't see this in the next 2 years, but now it's starting to make sense to me.
It's within the realm of possibility, more
exactly.
so than it was before.
It totally is. And if I'm in Intel's shoes, that makes me nervous, right? Like if I'm at Intel, this is really bad that if I can connect these dots, that's a problem, right? It should still be within the realm of absurdity. So these next couple of years, I think, are going to really define and change a lot. And I don't know what happens at the end of it. The other interesting thing that I noticed at IDF, and actually a friend of mine who works at Intel pointed this out, that the discussion at IDF wasn't about Intel competing with NVIDIA or Intel competing with AMD. The only questions people asked were about Intel competing with Apple. And that's a dramatic change from the way things used to be.
Really? All the discussions focused around Intel versus Apple?
What all the press were asking, like what everyone outside of Intel, like obviously Intel didn't say, hey, we're.
Well, I mean, the press is one thing, I guess. But I never know whether to chalk that up to just ignorance or, we want to talk about new shiny a lot.
Yeah, but it's clear, right? Like it used to be that AMD was such a threat, or that NVIDIA graphics were such an important focus that everyone would say, look, Intel, you're not catching up here. You're not doing what you need to do here. But now all the questions seem to be, okay, you're just clearly not doing enough in this space that Apple is very dominant in. And yeah, I think some of that is obviously the timing of the event. But the fact that that's where a lot of the questions were coming from it tells you a lot about where Intel needs to at least assert its dominance. Yeah.
I think, what was the standby power on Haswell, on the one that was under 10 watts?
They didn't say, right? So that falls under the obviously it's greater than 20x improvement of idle power compared to to Sandy Bridge, but
because I think a lot of people don't appreciate that there's active power, which in a smartphone is like a watt, maybe a watt and a half for the whole system, so really like under a watt for a CPU, maybe a watt, and then so that's when you're using the phone, like loading a web page, everything is fully loaded, everything is awake. But most of the time the phone is off in your pocket, and that's all standby power.
Yes.
And that's really where, if you integrate over all of that, that's where, the battery life concerns start to become really important. And even in our battery life test, there's a significant amount of time that's just idle, which is why, I think it's pretty realistic. And I don't know if people realize this, but on Android phone, you can go and get an app and look at the state table and the time spent in state, like CPU Spy, I'm always looking at. And, for like my phone right now, 31 hours awake, 15 hours were spent in deep sleep, 6 hours were spent in the lowest state possible, and then 7 hours were spent at 1.5 gigahertz. So, really, that's the breakdown if you want to look at what counts most for, power consumption, if you're going to like armchair engineer this. I don't know. See, another tangent. I don't know how I got involved on that, but yeah.
No. So you actually, no. I don't think it's a tangent at all. I think you hit on the exact point of Haswell ULT and beyond, right? That standby power matters so much that Intel had to go and stop. I mean, they couldn't stop at just the CPUs or the SoC silicon anymore, that they had to go in and now start specifying the rest of the platform. All right, not saying that they're going to make every chip on the board, but they're going to make sure you choose the right chip everywhere on that motherboard.
Which is so important in a notebook because, there it's kind of a free-for-all still.
Yeah. And so it's that I think standby power is very, very important. The other thing that they're talking about, which Intel's talked about for quite a while now, panel self-refresh. So the idea is that when you're so right now, if you're just sitting there on your desktop, you're still getting like the GPU's awake and it's still sending 60 updates a second to the display, even if nothing's changing. Panel self-refresh, you put some logic and DRAM on the panel itself. And if nothing's changing from what's being asked to be displayed, then it can actually just keep displaying the same image and tell the SoC and the GPU to power down completely. So that's at least what Intel's saying is they're really trying to make that happen finally. They've been talking about this for years. They're really trying to make that happen with Haswell and with these Haswell ULT platforms. Because that's an easy, like low-hanging fruit way of cutting down on platform power consumption.
Interesting. What is the normal notebook interface for display anyways? I can't remember what it's called anymore.
LVDS?
Oh, is that what it is? Yeah.
So it's either LVDS or EDP.
Well, that's good. At least it's not TMDS.
No, I mean, it used to be
moving away from TMDS.
Yeah. No, EDP, I believe, that's the kind of where folks are going now.
So just display port. Gotcha.
Exactly.
Embedded?
Yes. So panel self refresh, I don't know, that's really exciting because so then you could take it that's kind of the low hanging fruit, right? Then there's the next step where let's say all that's changing is the position of your cursor, right? And don't think about this in folks listening, don't think about this as well, I'm just leaving my computer at an empty screen for hours. Even if you can keep the CPU asleep for seconds or fractions of a second, that's still savings in idle power, considerable savings, right? And just looking at it at that granularity is important. But so you get to this point with kind of the next generation of panel self-refresh where let's say only the cursor is moving or a small percentage of the screen is changing. You can still do the same thing, right? Just move some of that, offload some of that update work onto the display and power everything else down. So Haswell is just really, the platform is just really about, it's truly a platform now. It's about using everything more efficiently. So yeah, that's the Haswell teaser. Brian, any last words before we end here? We're almost at the 2-hour mark.
You know what, I want to, it's dumb. So I have a little bit of congestion, which is why my voice sounds weird, but also I'm on the ear pods. Did you play around with your ear pods?
No, I haven't actually. There's still so Apple gave us all, they sampled us with the new headphones that are going to come with the iPhone 5 and the new iPod Touch. And they're called EarPods. So what do you think? You like them?
Well, they were like, it took 3 years of work and we 3D scanned everybody's ears and we came up with what the lowest common denominator for an ear hole is. And we engineered all these interesting and novel things like some sort of acoustic chamber and there's these little apertures. I mean, I think it sounds better. It's still not necessarily worth $30, but at least it comes with the device. It's substantially better than the old ones, which were terrible. They're just around way longer than they should have been. And when I look at those ones, I view it as they're sort of analogous to the original mouse, the Apple mouse that was like the UFO mouse.
Yeah.
They're circular and they looked cool, but they never fit in anybody's ears right.
Yes.
These ones do, but they're still not great. But the microphone is pretty good. I brought along some Logitechs, and this seems to be less noisy, less background hiss than those, at least on the microphone. But
so,
I don't know. I'm just curious what you thought.
No, I haven't even used them yet, man. I've been just traveling and trying to get stuff written up. I need to actually. I tried them on the plane,
and then I tried them when I was at home because I was like, I want to write. I need to include something about this.
No, I thought you did a great job on that. So here's the question: you said they're not worth $30. They're great for free, which is what you'll get when you buy a new iPhone, which is good. what would you buy, and at what price point? If someone wants a better, in-ear experience.
I think Sennheiser has a really good low end brand,
Yeah.
and I think they have some that are only $30. Sony does too.
Oh,
Honestly,
awesome.
I don't play in the like earbud thing as nearly as much as the IEMs, like in-ear monitors. Like I think earbuds are just going to sound terrible because they don't isolate.
So what's
Just
the
go to
difference
IEMs.
between IEMs and earbuds?
IEMs like seal against your ear canal. Earbuds just sit in your ear canal with no seal. Like
Okay.
these don't make a seal at all. In fact, they're open sort of with these weird apertures.
Yeah.
Whereas,
So
IEMs, you have a little foam thing that you crush up, and then you stick that in your ear canal, and then it expands and forms a seal.
okay.
So
So
I have a bunch of Sures that I use, and those sound great.
so Sennheiser at $30 for earbuds, and then Shure's at what price point for IEMs?
Ooh, I don't know what the SE 115s are great. Those are the lowest ends. I'm sure there's somebody I'm gonna get an email that's like, you should go with these. I don't know what like the best one ever is.
I
I
gotcha.
think
No, I'm
the
just looking
SE
for your.
115s are like $80.
Okay. Yeah. No, I
I
think
have
it's.
some SE 535s, which are like $500, and those are great. Like those are all I carry anymore. And
Yeah.
those aren't even as expensive as everything gets. Like I don't know, you can go to Ultimate Ears and get just like crazy things that are thousands.
Yeah. I'm probably under the like. I have the really old earbuds from the iPhone right now. That's what I'm using to record this. Not obviously for speaking. I've got the Blue Yeti here, but
Oh, to listen to?
yeah, to listen to. They're fine. Like I have so many of them that I can just leave them places, so I never have to like go hunting for them. They're just everywhere.
See, they're great for conference calls. They're just
Yes.
really great for that. Because you don't want to hold the phone to your head for 30 minutes.
Except maybe I do now with the new ear like noise canceling earpiece, right? That's a
That's true.
sensation that I just want all the time now apparently.
It's pretty different. It definitely feels weird. Like I think people listening to this, if the feature is enabled, hopefully they don't do anything crazy like disable it right before it comes out. But I think people will immediately notice that, and it feels weird.
So here's and let's end on this question. AT&T has stopped doing the, everyone gets the free upgrade, for $199 yearly for the iPhone thing. So now if you bought the 4S, this becomes a much more expensive upgrade if you're on AT&T and Verizon too, I'm assuming, right?
You got the 199 upgrade, really?
No, I didn't. They stopped that, right?
But I never got that, like ever, from 4 to 4S or 3GS to 4, 4 to 4S. I never got that. I always got like a partial update.
Really? No,
Partial
I had
subsidy.
it. I had the full subsidy for every generation of the iPhone. This is the first one where I haven't.
Weird. No, I always got the partial subsidy that was like, you still have to pay us $500, which is what I got this time.
Yeah.
And so
No, so
I used my gift card.
yeah, this was the first time for me that I had that. So the question is, do you believe that this is going to be a worthy upgrade, or is it too early to tell? Do we have to? We need
If
more
you're on
hands-on time.
Verizon, it's definitely a huge upgrade just because of LTE. Like eVideo for me is miserable.
Yes.
If you're on Sprint and you're in one of the lucky LTE markets, same deal. I think yeah, LTE is just a big thing, and I think for a lot of people they're going to be very surprised about how much different it feels. You know, I read a lot. Do you really need 20 megabits on a phone?
Oh, totally.
And I think the answer is yes. Yeah, because of those peak moments when you're loading things initially, the throughput does matter.
Yes.
And an OFDMA release just in general is so much better in terms of the weird when you're in weird situations with noise and it using the right subcarrier that has no noise, no fading. I think it's worth it. Yeah, if you're on AT&T, it's maybe not as much, but if you're on Verizon, this is like a huge step forwards.
Yeah, that's true. I guess I didn't even look at it from that respect because I always forget how slow eVideo is.
It is really slow. Yeah.
Yeah.
Yeah, it is really slow, sadly.
Okay, well, I think that's a good note to end on. Brian, enjoy the rest of your time in Korea, and I I guess the next episode we do will obviously touch on more of the IDF stuff, begin to touch on how iPhone 5 testing is going, as we'll be just starting on that pretty much. So yeah, that's all. Thank you all for listening. And of course, thanks everyone who helped stress the servers out with the live blog and for supporting us there as well. And we'll talk again in a week.
Yeah, see you then.